Welcome back to this version of Miss Max Academy. Today we're doing question number 13 on the handout, which asks us to reflect triangle JAR over a series of different lines. In question 13, we're asked to reflect triangle JAR over the line x equals -1. Well, before we do that, let's just make sure we understand what we mean by reflection. Well, the idea of reflection is we're going to flip an object across a line. So of course we need to draw the line. What does the line x equal to -1 looks like? Well, that line, for every point on that line, has an x value equal to -1. Let's identify our origin. And we know on every line there are infinite many points. Well, all of our points will have an x value equal to -1. Well, here we have a point -1, 0. That must be on our line. Here we have a point -1, 1. Here would be the point -1 up 2. Again, from the origin, left 1 up 2. Okay? Here would be the point -1, -1. So clearly, you can see the graph of the line x equal to -1 would be a vertical line, and all points on this line would in fact have an x value equal to -1. Okay? We also know that when we reflect an image, when we reflect an original polygon, its image and pre-image are congruent or isometric. So remember, this is called the pre-image. This is the image before movement. Once we've flipped it across the line, we will call it the image. Okay, and that's the polygon after the transformation has taken place. So here's our pre-image. That is the polygon before the transformation happens, and we're trying to create an image, the polygon after the transformation happens, or after it has been flipped across the line. Well, what else do we know about reflections? We know that the line of reflection, which is this line right here in orange, is the perpendicular bisector of the segment connecting each point to its image. Well, first of all, if this is our line of reflection, and it is a vertical line, we know the only type of line that would be perpendicular to a vertical line is a horizontal line. And we want to connect R to some point R prime. So I'm going to draw a horizontal line that passes through R. Okay? So let's go back and read this again. The line of reflection is the perpendicular bisector. Well, I clearly have perpendicular here. You can clearly see the right angle, right? Well, what do we mean bisector? Well, a bisector cuts a segment in half. Well, what segment? The segment connecting each point to its image. Well, here's my point R. And right here I have 1, 2, 3 units to get to R. 1, 2, 3 units give me to R. Therefore, I have to continue along that path. 1, 2, 3 units. This must be where R prime is. Well, how did I know that? Well, I know that the line of reflection has to be perpendicular to the segment connecting each point to its image. So here's my line of reflection, x equal to -1, this line right here. It is clearly perpendicular to the segment connecting R to R prime. Not only is it perpendicular, but it cuts that segment in half. We have 3 units to the left of their intersection and 3 units to the right. So I know, in fact, R prime is in the correct location. Just going to erase just a little bit here so I can clear up my diagram. And now I know where R prime is, and I understand that the line of reflection is the perpendicular bisector between each point and its image. And R prime tells us that point R has been moved one time. Okay, so again, I'm just going to move on and move the next point, J. Well, again, the only type of line that would be perpendicular to a vertical line would be a horizontal line. And this horizontal line needs to connect J to J prime. And not only does it have to connect them, but it has to bisect them. So J prime has to be right here, right? We see the right angle, and we see we have 2 units to the left of the intersection and 2 units to the right of the intersection. Okay, so if this was point J, J prime would end up over here if we flipped it across the line. It was 2 to the right, and it's kind of like we have a piece of rope, and we're holding the rope here, and we're swinging it over there. Okay, flipping it across the line. All right, so now here's J prime. Again, I'd like to erase that just so I can clear up my diagram. And last but not least, I need to move A. I have to reflect A. And again, the only type of line that is perpendicular to a vertical line is a horizontal line. From A to the perpendicular bisector is 1, 2, 3, 4 units. So I'm just going to continue along that same path. 1, 2, 3, 4. And here must be A prime. You can clearly see that this segment is perpendicular to the line of reflection, and you can see that this segment from A to A prime has been bisected. So again, the line of reflection is the perpendicular bisector of the segment connecting each point to its image. And we've used that definition to repeatedly reflect each point over the line x equal to -1. All right, so now we just need to complete our triangle. Our new triangle would be called triangle A prime, J prime, R prime. And our final product should look something like this. Okay, so here is our original polygon. And a reminder, we call the original the pre-image. That is the polygon before we've moved it. And here is our image after we have reflected the triangle over the line x equal to -1. Tune in again for the next episode of Miss Max Academy.